Good morning, everybody. Morning, students. Can you hear me? Hello?
Yes, sir. Yes, sir.
Can you all see the screen as well?
Yes, sir.
Okay, so this is more revision, guys. More math equals better math, so I'm gonna do a little bit of revision here today. And moving on to a new topic from tomorrow. So it's that time, All right. All right, so I'm going to revise using some of the questions that I sent you to do. And also going to do the class activity that we had the other day. All right, so basically looking at stuff that you're familiar with, not a problem. And so we'll be able to solidify some of what we've been doing. All right, the content for today is nothing new. Everything is, what you've been exposed to before. All right, so this was some questions that I sent the other day. I'll give you about 10 questions. I just want to run through these 10 questions. Quick and fast. I also sent a couple questions last night, and then I also want to do the class activity. Since I already have this up on the screen, let me just work with this for now. All right. Let's just work with this for now. All right. So this question says, if the sum and product of the roots of a quadratic equation are S and P, respectively, so the sum is S and the product is P, which of the following is the equation? So this is a knowledge-based question. This question is testing your knowledge. And the answer for this one is here. And see, you have to pay attention to the details, but they're all very similar. But the particular one that is correct is actually this one. And this is just something that you must know. That's as simple as that. This is something that we proved in the class, but now it's a matter of knowing it. So it's x squared minus the sum times x plus p equals 0. So remember now, a number of persons forget to put the x right here and also to forget to put the equals 0. All right. Then the questions that follow is testing our knowledge, our application of this. All right. That's what the question next will do. Test our application. And I can basically just work it on the screen. Let me just do that. So this one says no. This one says, if the roots of a quadratic equation are -2 and 5, which are the following could be the equation? So we're using this thing again about the sum and the product. The same formula we're using, that x squared, this identity or result, x squared minus the sum times x plus the product will be equal to 0. All right, so we're going to sum these two and do the product of these two. So we're using this expression, this as our equation, then it would be x squared minus the sum. I'm going to put the sum in bracket. I'm going to put the sum of these two, which is to add them. So -2 plus 5, that is the sum. Don't forget to put the x. Don't forget to put that x. Plus the product. The product is when I multiply these two. So it is -2 times 5, and then that is equal to 0. All right, so this right here is the sum of -2 and 5. This is the product. So it becomes x squared minus, now what is this? This works out to be 5 minus 2 is 3. That is 3 times this x. And then this product becomes a -10 minus 10 equals 0. So which one is that? Minus and minus, right? Minus and minus. So the answer for this one is the last one right here. Let's mark it in red. What are you good with that? Everybody understand that? But okay?
Yes, sir.
All right. Then they give us another example and basically using the same values. So the sign switch around, right? So again, we're using the same formula. I don't want to, well, same expression, which is x squared minus the sum times x plus the product is equal to 0. A quadratic equation can always be written in this format, right? When you know the two roots. And then using these two roots again, which now is 2 and negative 5, it becomes x squared minus, I'm putting this minus first. I'm going to put the sum in bracket, which is 2 and negative 5. 2 and negative 5 times the x. A lot of people keep forgetting the x. And I'm going to add the product. Product is 2 times negative 5, and that is now equal to 0. Well, what does this work out to? That works out to negative 3. So it's x squared minus 2 minus 5 is negative 3 times this x. And this 2 times negative 5 is negative 10. So plus a negative 10 is just negative 10 equals 0. And then this minus minus becomes a plus. Minus minus 3 becomes a plus 3. So it becomes x squared plus 3. Don't forget the x minus 10 equals 0. Which one is that now? A plus and a minus. So it is this one here. The plus and a minus, this one. You see, they all look alike. Having the same value, just the sign that is changing. All right, that is that one. But okay, we'll move on. You okay? The answer, guys, this is not just me alone. It's not a monologue, it's still a class. So you have to respond. Unmute your mic, respond, and then you mute it again. But okay?
Yes, sir.
All right. And then now we have the same thing again. We have these two roots. Those are the two roots, and I want to form the equation again. Again, the equation will be x squared minus the sum of the roots times x plus the product of the root equals 0. All right, and these are the two roots again. So it's going to be x squared minus the sum of these two roots. It's going to be 2 plus 5 times the x plus the product of those two is going to be 2 times 5. And that's all equal to 0. Now this right here is 7. 2 plus 5 is 7. So it becomes x squared minus 7 times this x. And then this 2 times 5 is at 10 plus 10 equals 0. So 7 and 10, and it's minus and plus. So looking for that. Minus and plus. So it is this one now. This is the answer. More math equals better math. So we'll do it again. We're doing it now with negative 2 and negative 5 as the roots. Right? So we're doing a full combination of 2 and 5, positive and negative. So the same thing again. Those are the two roots of the equation. The equation would be x squared minus the sum of the roots times x plus the product of the roots equals 0. By the time you write this thing a number of times, you can't forget it, right? That's why we have to do more maths. So the thing stick. All right. So again, it's x squared minus, I'm going to put the sum inside here in the bracket, which is negative 2 and negative 5. Negative 2 and negative 5 times the x. Don't forget the x of people forgetting that x. And I'm going to add the product of negative 2 and negative 5. Negative 2 times negative 5. That's a product right there, equals 0. And shift this over a bit. Equals 0. That's what we have. Then this negative 2 and negative 5 is negative 7. So it becomes x squared minus a negative 7 in the bracket times x. And then this negative 5 times negative 2 becomes a positive 10. Positive 10 equals 0. All right. And then this minus minus is a plus. Minus minus is a plus. So it becomes x squared plus 7 times this x plus 10 equals 0. So it's plus and plus this time. Plus and plus. So that says A. All right. The next question is asking us for the expansion of this term squared. It's really this. This is it. Right. It's really 2x minus 5 squared. What is the expansion of that? Now, what I told you was that when you expand a perfect square like a plus b all squared, the quick way to do it is to say from the first term squared, which is a squared, then twice the product of the 2. All right, so we're going to multiply these two things and then double it. So it becomes plus 2 times ab. So multiply the a times the b and then double it. And then we go the second term squared, this term squared, that b squared. Now, this is plus right now because you actually multiply a and negative and plus b. These are the two terms. A like a plus a and a plus b. That's what we have inside here. So you multiply plus a and a plus b, we get positive ab and we have double it. All right, that's what it is. So this time, I'm going to show as well a minus b squared. So in this case, the two terms are a and minus b. All right, but they are a, which is a plus a really, a plus a and a minus b are the two terms in the bracket. All right, so if I apply the same expansion, then the first term squared, which is a plus a squared, becomes a squared right here. And then we're doing twice the product of the 2. So it's like we're multiplying the a and the minus b. We're multiplying them. It becomes minus, it becomes minus ab. But then you have to double it. So it becomes minus 2ab in the middle right there. Twice the product of the two things. So minus 2ab. And then the second term square, which is the minus b. So like you're taking minus b and you're squaring it to put it here. So the second term squared becomes a plus b squared. If we square a negative number, negative value becomes positive. And that is it. All right, so that's what we're applying now to this expansion. All right, so it's a little smaller. I'm doing this expansion now, which is a 2x minus 5 squared, and within one step, it becomes the first term squared, squaring that first. So if we square 2x, it's going to become 4x squared. Then we're going to go twice the product of the 2. First, the product of this and this on the negative 5. That product is negative 10x. So you're doing twice, you have to double it. Double it, so multiplies by 2 for the middle term. Twice the product of the 2. So multiply the 2 values first, you're going to get negative 10x and then double it. For the middle term, you're going to be negative 20x right here. And then the second term squared, the negative 5 squared becomes a positive 25. A positive 25 right there. And that's it. But I go to that. So the first term squared, twice the product of a 2. This is the one that people forget. Twice the product of a 2. How do I get that? I multiply the 2 values first, and I get negative 10x. And then I double it to get the middle term because it's twice the product of a 2. All right? You have to learn to do mathematics the easy way, quick and fast. But all right with that, is there anything there somebody don't understand?
Yes, sir.
Very good. All right, cool. Then down here, for number 7, I said, these are two simultaneous equations. what is the correct substitution of a line into the curve? So this one was just testing our ability to substitute a line into the curve. What it is that this one is a line. One is a line. But the x and the y values are separate. And then this one is a curve. The curve is the one with products and quotients of the variable x and y. Because our x gradient and our y gradient, so we know it's going to produce a curve. So this one is a curve. All right. Now, normally with the line, when you're going to do a substitution, you make one of the subject, one of the variables the subject. It's easy to make y the subject. All right. I'm going to write back the line, but put y as a subject. So the line becomes y equals 5 minus 3. That is the line. This is now that. And I transpose the traits. All right. And then the curve is still x squared minus 3 times y squared. That is equal to 2. So at the point of intersection of this line and this curve, the x values are the same. So this x value, we have a different color. This x value is equal to this x value. They are equal at the point of intersection. They are the same. They have the same value. And also, this y value is equal to this y value at the point of intersection. Right now, this y value on the line is actually equal to this thing. We just don't know what the actual value is because we don't know the x yet. So let's say that it is equal to, let's say that this would work out to 5. So let's say that this would work out to 10, for example. Assuming. Then it means that this value on the line, on the curve, would also be 10. It's just that because it has an x in it, we don't know what the absolute value of this is yet. The y, we don't know what it is. But it could be 10, it could be 15, it could be negative 6. Whatever value it is here, this has that same exact value at the point of intersection. So even though we don't know the precise value that the y is on the line right now at the point of intersection, we can use all of this to represent the value of y on the line at the point of intersection. And we know that the y value on the curve is going to have the same, it's going to be the same value. And that's why we can take this and replace this on the curve, substitute it, because it is the same value. And that is how you substitute the line into the curve. You really substitute in the value. It's just that we don't know the absolute value of this because we don't know what the value of x is. If we knew the value of x, then we would know this as a number, as a value. We could be able to work it out. So even though we don't know what it is as a value, we know that on the curve, the y has that same value. And that's why we can replace the y with this. The y is equal. All right? That's a chain of thought. Because at the point of intersection, the x value on the line and the x value on the curve is the same. The y value on the line and the y value on the curve is the same. Right now, the line is saying y is equal to this value. So the y value on the curve is the same. And that's how we can make that substitution. We can replace it. And we'll make the substitution now. So we're going to do the substitution. We're going to sub the line into the curve. All right? I'm substituting for the y value. And the y value on the line is this that I've circled in red. I'm going to put that value now in the curve. As I said, if it was at 10, we will put in a 10 right here for the y. We just don't know what the absolute value is. So we're going to put it there as it is now. 5 minus 3x. We're going to use that as the value of y at the point of intersection and put it into the curve. Because you know the curve and the line, they have the same y value. And they also have the same x value, but we're substituting for the y value right now. So when we do that substitution, this same equation, this curve equation is going to become, we'll put the y value in there, it's going to become x squared minus 3, where the y is, we're putting the 5 minus 3x. And don't forget the square that is on the y. And then we'll put what it equal to. Let me sample it. Equal to. And that's a substitution. And this question was just testing if you know to substitute correctly. That's what you would get. Which one of them match this thing? Looks like B. Looks like B to me. This one right here. X squared, minus 3, minus 3. 5 minus 3x all squared. 5 minus 3x all squared equals 2. Equals 2. The answer there is 2. I did not ask you to solve it. I just wanted to see if you know to make the substitution. Everything is important. But good at that? But okay? Students, everybody okay?
Yes, sir.
All right. And I think that was it. That was it. Then I also gave you some graph questions. Then let me go back and look. Gave you, that was number 7. I gave you a number 8 and a number 9 and a number 10 right here. I also gave you this to do, number 8. All right, I'm going to work that out over on the right side of the page. So this question, what it is now, we are applying what we just did in those first couple examples. But this time we're looking at a graph. That's a smile shape graph. So because it is a smile shape graph, before you even start to do any work, right, you know that this A right here is positive. Because when the square term is positive, you get a smile. But what we can see on this graph are the 2 roots. Then they are giving us the roots as values, then I'll put it on a graph for us to see. So this equation has 2 roots. And what it is that we want to work from the roots and work back up to the function. All right, we want to get back to the function. Remember, guys, it is the equation, the quadratic equation that gives you the 2 roots. So you have to go from the 2 roots back to the equation first. And the equation is 1 with equals 0. And then from the equation, we can go up back to the function. I don't want us to jump over the equation because you get the roots from the equation. So from the roots, you can go back to the equation. All right? So in this example, the roots are negative. The roots are -1 and 6. And we want us to find the A, B, and C. In other words, they want us to form the function. So we can see what A, B, and C is. And after that, we are required to state the coordinates of P, which in this case is the y-axis intercept. It's the y-axis intercept. All right? All right. And the y-axis intercept, as you know, is taken from the C value in the standard form. So let's go. So from this now, we know that the roots are -1 and 6. When we know the roots of a quadratic equation written in terms of the sum and the product of the roots would be x squared minus the sum of the roots times x plus the product of the roots equals 0. So these are the 2 roots. We need to put the sum of them here and the product of them there, of those two roots. Those are the two roots. All right? That's what this is all about. We're forming the equation first, and then from the equation we'll go to the function graph. Remember, the function is for the entire curve. The equation gives us the two roots alone. All right? So we're going to form the equation first with the equal 0. So let's do it. So the equation becomes x squared minus the sum of these two roots. Now I'm going to put them there. So the sum will be -1 plus 6. Don't forget the x. Plus the product will be -1 times -6 times 6. -1 times 6. -1 times 6. Mute the mic, please. Equals 0. So this inside here so becomes a 5 because it is 6 minus 1. It's a 5. So this becomes x squared. That is this minus I'm putting back here now. Minus, this is 6 minus 1 is 5 times x. And then this -1 times 6 becomes -6. All of that becomes -6 equals 0. So that is the equation. This is the equation that would have given us these two roots if we were to solve it. So I've gone from the roots back to the equation. All right. Now, remember, the equation is really just about these 2 points. Right? It's really only about these 2 points. The equation is really only about this point. And, sorry, did something wrong. Right? The equation is really only about that point and that point where the roots are. We're now interested in getting the entire curve. The entire curve is represented by that function, but they are related. So the equation is related to the function. So you have to check now if that equation is related to this particular function graph. Why do we need to do that? Because we could have a case where we have, instead of a smile graph passing through these two roots, could have been that we have a frown graph passing through the same two roots. And the fact of the matter is that this frown graph would have given us the same equation down here. X squared minus 5x minus 6 equals 0. Just as though this one gave us x squared minus 5x minus 6 equals 0. Because this equation would give you these two roots from that smile graph. This equation will give you the same two roots from the frown graph. So a smile graph can give you the same two roots as a frown graph. Right? So the equation that give you the two roots can be the equation from a frown graph or from a smile graph. In this example, we actually have a smile graph. And so we have to check if the smile graph and the frown graph, if they match each other, if they are in sync. Is this smile equation related to a smile graph? And the answer is yes. How do I know it's a smile equation? Because in this equation, the square term is positive, so we can say it relates to a smile function. Additionally, this C value in the equation would be in sync or would be consistent with a negative y-axis intercept. Remember, the C in the function relates to the y-axis intercept. Right? So everything is matching right now. It is consistent. So this smile equation right here is consistent with this smile graph that we have. Why? Because the square term is positive, and that's when we get a smile shape. And then the C value is negative, and we have a negative y-axis intercept right here at 2. It's on the negative side of the y-axis. So the smile graph right now is the graph and the equation match. They are consistent with each other. You can make a note of that. So this equation matches, I can say it is consistent, matches the function graph. What is the difference? The function is the entire graph. The equation gives you just the two roots. So the function is the entire graph, but the equation is give you just the two roots. When you solve the equation, you get just the two roots alone. And remember, what we were saying is that a thorn graph would give you the same two roots. It can have the same two roots. All right? So right now, this equation is consistent with the smile graph. And so therefore, we don't have to make any change. It means that the function will have the same expression in it. So we can write that. Function, therefore, function is y equals the same expression. They are related. The equation and the function graph are related. X squared minus 5x minus 6. I don't have to put the equals 0. Because equals 0 is for the equation that gives the roots. The function is for the entire graph. So they are consistent with it. And then based on that, now we can find the A value of A, B, and C. They gave us ax squared plus b plus c, which are coefficients. So it means that the A is equal to 1. And coefficient of this x squared will be a 1. So A is 1. The b is this term and this term now. Plus bx is minus 5x. So the b is minus 5. And this plus c is negative 6. So the c is negative 6. So the c is negative 6. Then the next part 2 right here, is asking us to state the coordinates of this point. That point is the y-axis intercept. All right. So the point P will have coordinates 0, C. As at that point, the x value is 0. If the x value is 0. So we take the x value of 0 and you plug it in the function here and there. The y is going to be equal to just the c value alone, because this will be equal to 0. All of this will be equal to 0. So the y will be equal to the c value alone. All right? And so that's why I'm c value inside here. But this is stuff that you just know, that the y-axis intercept is 0, c. All right? So it becomes p is 0, negative c. That's the point. But okay with that? We know coming off this topic now and again. So our last chance to get these things apart from the revising. Coming off this topic now. Going on to from tomorrow. All right? Coming off this topic.
Oh yeah, watch show and watch fucking masters. Give it one.
Hey, Jesus Christ. Oi. Oh Lord. Mute your mic, please. Sorry about that, guys. All right. Somebody in the class and watching other stuff. All right. Then now we come to number 9. And the difference with this one now is that we have a frown. So we know off the bat that the squared term has to be negative. The squared term has to be negative. So the p has to be a negative value for that frown. But again, it's a case we're represented with two roots. That's what we know. You can see the two roots here. All right? So that is it. So based on that, we can form the equation again. Remember, you go from the roots to the equation, because it is the equation that gives it the root. The equation is equals 0 business. And then from the equation, you go to the function. Remember as well, that we could have a smile with the same two roots. So the frown graph would give you the same equation as the smile graph. All right, the frown graph will give you the same equation as the smile graph, because remember, it is the equation that gives it these two roots. So we're working back from the root to the equation. When we reach the equation, we're going to have to check to see if the equation is consistent with the function graph. The function is the entire graph. The equation just gives us these two roots alone. I want you to watch back the video and listen to me repeating the same thing over and over again until I get it. Everything important. All the minute details, very important. That's how we understand this to a level, to a point where any way to change the question you put to go. You have to understand every minute detail about it. All right? So we're going to form the equation from the roots. So in this number 9 example, that we can see the roots again. So the roots are -1 and 8. Those are the two roots. When you know the two roots, you can form the equation that these two roots came from. That equation, really in terms of the sum on the product root, is x squared minus the sum of the roots times x plus the product root equals 0. Just that this equation that we always use relate to a smile graph, but it could come from a frown graph as well by making changes. But to start, we always start out with this equation. That's a standard way to start. All right? That's a standard way to start based on the proof of this expression or prove that expression, which we did in method. We're going to form the equation that would have given us these two roots first. Going from the roots to the equation, then from the equation to the function. Remember, the equation is what gave us the two roots, and the equation is all related to the two roots. The function is for the entire graph. All right, and we're trying to get function, which is for the entire graph, not just the two roots. All right, we're going to do the same thing again. So the equation becomes x squared minus the sum. I'm going to put the sum in the bracket. -1 and 8. We're summing those two values, two roots. -1 plus 8. That's a sum. Don't forget to put the x. Then we're going to add the product. We're going to multiply these two roots for the product. That's -1 times 8. And that is now equal to 0. This -1 plus 8 is the same as 8 minus 1. 8 minus 1 is 7. This is x squared minus, coming here now. And then this inside here works out to 7 times back this x. Take the time. Then this -1 times 8 is -8. There's a positive plus -8 is the same as -8 equals 0. So that is the equation that would give us, this is the equation that would give us these two roots. Just that this equation now relate to a smile function because the square term is positive. But what we actually have is a frown function. So they're not really consistent right now. The equation and the curve are not consistent. Additionally, this has a C value that is negative. On a smile graph, that would intersect x-axis somewhere below and intersect the y-axis somewhere below here. What we actually have in reality on this curve is one that is above the x-axis, a positive C. And that again is inconsistent. But right now, the curve and the equation that gives us the two roots and this function graph over here, they are not related. They are inconsistent. And so we have to make an adjustment to the equation to bring the equation to be consistent with the function. So let's write this now. They don't match. They are inconsistent with each other. This equation relates to a smile function graph, but we actually have a frown. And the mathematics must be consistent. What you have by calculation, what you have on your diagram must be consistent. Remember, it is just that. It could have been that we have a smile with the same two roots. If it was a smile that we have that I'm drawing now with a purple, with the same two roots, then this and this would match. They would be consistent with each other. But we don't have that consistency right now. All right? So we have to make that adjustment. So this does not match. This equation does not match the function graph. They don't match. To make them match, we need the square term to be negative to produce the frown, and we need the C value to be positive because we see we have a positive C, positive place where it goes to get. And the easy way to make them match is to just negate this equation. To negate this equation, we simply multiply 2 by a -1. We take this equation right now, I will multiply by a -1 right through. Then all that will happen is that we will end up with the equation now that is consistent with the function graph. So you negate this, it becomes negative x squared. You negate this negative 7x, it becomes plus 7x. You negate this 8, negative 8 becomes plus 8. And then this time -1 is still 0. 0 times -1 is still 0. So you get 0 over there. This equation now would still give you these two roots. And it relates to the function graph now. So this equation is now consistent with the function graph. There's a match. So this now matches the graph. We can write this is now a match. This is a match. This one, this is a match. It's consistent with the graph now. And because we know an equation that matches the function, we can now write the function with the same quadratic expression. So the function is y equals -x squared plus 7x plus 8. And don't put equals 0 because we're writing the function now, which gives you the full graph. Remember, the equation is just giving you the roots. The function is what gives you the entire graph. And so this is a function for this graph over here. Right? And then we can write in the value for P, Q, and R by comparing the coefficients. We can write it. So the P becomes the coefficient of the x squared, which is a -1, even though the 1 is not shown. -1. The Q is the coefficient of the x, which is the 7 right here. And the R up here, the R up here is this constant value of 8. Those are the value for P, Q, and R. And then now C is the y-axis intercept. So it will have this value as a y value. And on the y-axis, you know the x value is 0. At this point, we'll have coordinates 0, R. In this case, R value is 8. So S is the point, 0, R. It's like the C originally, 0, R this time. And it is 0, 8. That's the point S. 0, 8. Any questions there?
No, sir.
Then I gave you number 10 to solve this pure simultaneous equation. Right? Pure simultaneous equation to solve. And I told you, because we have a plus y and a minus y in the two equations, we could actually use an elimination method by adding the two equations. We could eliminate the y. We could add the two equations. I want to do it both ways for you. All right? Let's do it both ways. And some of the simultaneous equations of a line of curve can be done by elimination sometimes, right? So this one is a line. You can see the value is separate. X and Y value is separate. This one is a curve. That's a discrete term here. That one is a curve. All right. So let me write them out. Let's use the elimination method first. We're going to just get to the equation. So we have x plus y equals 4. And we have x squared minus y equals 2 minus 4x. Again, because this has a plus y in it and this has a minus y in it, if I add the two equations, then the y values will be eliminated. We're using an elimination method now. So we're going to add the two equations, right? We're going to add the two equations, add them. Or you add the two equations, you add up everything that's on the left side together, and you add up everything that's on the right side together. That's why you add them, all right? And you have to add like terms. So if we're adding two equations, right? So we're adding two equations. So therefore adding up everything on this side, putting everything together. All right? So when you add, this is the only x squared term on the left side. You're adding up everything on the left side together first. Putting it all at one, adding up everything. This is the only squared term in it, so it remains x squared. This is the only x term there. That's a plus x. And then this y and this minus y, if you add up everything, they eliminate each other. So y minus y is 0. So the left side becomes that. All right? Equals. I'm going to add up things on the right side now. Add up everything on this side. And you're adding the like term together. This 4 and this 2 add up to 6. And then this negative 4 not adding to anything else. It's just negative 4. It comes back as negative 4x. Negative 4x. I mean, negative 4, negative 4. That is the right side. That is it when I add the two equations. So this now is basically a quadratic equation. But we have to transpose it over into the standard form because, as we say, we don't solve basic. When solving our quadratic equations, we make sure that it is in a standard form. The standard form is when you have the x squared term first, and then the x term second, then the c term equals 0. That's what you want to get it to look like when you're solving it. And a good hint, a good tip is, remember, keep the squared term positive. Always try to keep the squared term positive when you can. The less mistakes are made when the squared term is positive in quadratic equation. All right? Try to keep the squared term positive. Rearrange it in a way such that the squared term is positive. Now we're looking at this now. We want to transport it into the standard form. We want to get 0 on the right side. We want to get that equals 0. And everything on the left side. This is the only squared term in it, so it comes back as x squared. We're looking for the x terms now. We have an x term here and an x term there. So I need this minus 4 to come on the right side. When they come over on the right side, it's going to become a plus 4x. Then the plus 4x and the plus x becomes plus 5x, as easy as that. So that's going to become a plus 5x. We're going to put plus 5x. Then I have this 6 on the right side. And bring it over this side, it becomes negative 6. Minus 6. And I'm left with 0 on the right side. So this is my quadratic equation now that I got when I put those two equations together. I'm trying to find where they intersect each other. All right? So I need to solve this. I'm going to solve it by factorizing, but I'm not going to go through the process of factorizing. I'm just going to do it because we're focusing on quadratics. So the factors of the x squared are x and x. Factors of 6, where the difference is 5, is 1 and 6. 1 is the difference of 1. When this last one is negative, I want the difference to be the middle term. All right? So it's 1 and 6. And this tells me now which product must have the positive sign. Which product am I talking about? Is a far product and a near product that add together to give you the middle term. And since the middle term is positive, you want the larger of the far and near product to be positive. The far product out here is 6x. The near product inside here is 1x, 1 times x. This one is larger. It must have the same sign as the middle term. So to make it positive, you have to put the plus over here inside here. So put the plus inside here to get it to be a positive 6x. And then this now has to be negative. So you put the minus here. Because 6x and minus 1x give us the 5x. That is it. So those are the factors. And with those factors, remember, is either this equal to 0 or this equal to 0. Now look, if this is the one that is equal to the 0, and you're trying to make x a subject, you just need to take this negative one and bring it over and it becomes a positive one. And so this factor is giving me x equals 1. Or if this one was equal to the 0 and try to make x a subject, you have to take this positive 6 and bring it over the equal sign to become negative 6. And so the x will be equal to negative 6. So these are the two x values where the line and the curve intersect each other. Those are the two x values. I need to find a y value to go with this and a y value to go with that. All right? But before we do that, I'm going to show you now the substitution method that we could have used to get the same equation here using a substitution method of that same equation. So let me do it again over here. Let me do it over here on the left side. So there are side by side. Let me do it right here. All right, so the same two equations again. I'm doing it again on the left side now. All right, so we have x plus y equals 4. This is the line. What I'm going to do, I'm going to make the y the subject by transposing the x. So I'm going to get y equals 4 minus x when I transpose this positive x over here from negative x. I'm going to work with this as my line now. This is my line equation. All right, and then I'm going to write the curve. So the curve is this one, the same curve. It is x squared minus y equals 2 minus 4. This now is the curve. And this time I'm using a substitution method. What am I going to do? I'm going to substitute the line equation into the curve equation, just as I explained earlier, because this y value and this y value is the same. Just as the line is sitting that the y value is actually equal to this. And this y value and this y value is the same. So it means that I can take this and substitute for the y inside here. Get the same value at the point of intersection. So that's why I'm going to substitute the line into the curve for y. Let's write it for sub sub line into curve for the y value. All right, so we're substituting it, we're going to write what this becomes. This is going to become, when we do the substitution, it's going to become x squared minus, and then this y value now I'm going to replace with the 4 minus x. That's what the y becomes. This is where y was. Equals this thing now, 2 minus 4. I'm going to expand this away. I'm going to get x squared is minus 4. And this minus becomes a plus 5, plus x, sorry. And I'm left with 2 minus 4 over here. Then I don't want these over here now, right? I want to transpose these values over to this side. Remember, I'm trying to set up the standard quadratic equation, right? So let's do the x squared term first. This is our x squared term. I'm going to write it first. X squared. X squared. Then this is the x term. And this minus 4 is going to come over here and add to this x and give me a plus 5x. Okay, plus 5x. And then this 2 is going to come over here and become a negative 2 along with this negative 4. So negative 2 and negative 4 become negative 6. Equals 0. And so that is the same equation that I have here. Same equation, right? So when I solve this equation now, what here, this is going to carry me down to the same 2 x values. X equals 1, x equals -6. All right, so come back to the same place that we were before. Just that now, I have to find a y value to go with this and a y value to go with this. We normally get it from the line equation. A line equation has y as a subject. Try not to use a curve equation to find the other values type. Always use a line equation. The occasion we can use a curve equation depending on the type of curve that you have. But especially a curve with the squared in it, you don't want to use that. Right? The line is always easier to use. So I'm substituting this line equation, y equals 4 minus x. So let's take, we're going to sub now into the line equation, which is y equals 4 minus x. Let's do the 2 points. Firstly, at x equals 1 right here. You take this 1 and you plug it into the equation there. And the y is 4 minus 1, which is at 3. And so 1 point will have these coordinates, 1 and 3. This is the x value, this is the y value. 1 point of intersection is 1, 3. Then there's a second point of intersection where x equals -6. You can say at x equals -6. I'll take the -6 and plug it into the line equation there. All right? So the y at that point is 4 minus and -6. Remember, the x value is this -6 there. That becomes 10, because minus is a plus. 4 plus 6 is 10. So the second point will have these values, -6, 10 as a coordinate. So the second point is -6, 10. But go with that?
Yes, sir. Yes,
I
sir.
do the 2 points of intersection of the line on the curve. All right? So more maths equals better maths. So then I gave you a classwork, right? I'm going to run through the classwork again now. All right, we're covering everything. We're coming off this now, guys. We are coming off this thing. We'll tell you now. I'm going to find the classwork. All right, hold on. We are coming off this thing. We are absolutely moving on to a new stuff, new material now. All right, the last project. So, this classwork. All right. I'm going to run through it now. One more time. Moving on from this. We are moving on. We are growing in the subject. Getting better. All right. Progress before perfection. A little bit at a time. All right. So this was the number 1 question right here. All right. So the same thing again. They gave us a graph with these 2 roots. So that one is a fraction. And they told us that this was the equation, that was a function, sorry. And that P, Q, and R are integers. Now this thing is important. These are integers. Meaning that the P, Q, and R are whole numbers. So even though one of the roots is a fraction, we'll form the equation that ensure that we have whole numbers for the P, Q, and R. And then we're going to write the function. So we have to know how to eliminate the fractions out of our equation. So we're gonna get the equation from these 2 roots. But based on what they have said, coefficients are integers. Integers are whole numbers, positive or negative whole numbers. That's what integers are. All right. So this is another question of the same thing again, just that we know have a fraction in it to get rid of. No problem. Fraction is just another number. Let's just say, just like it's not whole, but we treat it the same way. All right. So in this example, again, we're starting from the root. You see the repeat of the same thing. The root are minus half and 3. When we know the roots, we go back to the equation first. Remember, don't just go to the function yet. You go back to the equation first. So with those roots, the equation would be x squared minus sum of those two roots times x plus the product of those two roots equals 0. Now, sometimes you can work out the sum of the two roots by itself and then the product by itself, and work them out by themselves, and then plug in the values in there. You can do it that way as well. But I'm going to put them in as we've been doing since we started. So I'm going to write it and put the sum of these two roots in this position and put the product in that position, right? And work out itself. So this equation now becomes x squared minus the sum of the root will be minus half plus 3. Don't forget the x. The same here is the sum of the roots. Plus the product now is when I multiply these two roots together. So it's minus half times 3. It's a product equal this 0. I just need to work out this now, right? All right, so it is x squared minus negative half. I want to turn this into a fraction with a denominator of 2. Because this one has a denominator of 2. I want to turn this into a fraction with a denominator of 2. Because when you're adding or subtracting fraction, you want them to have the same denominator. You want them to be related. So since I want to turn this into a fraction with a denominator of 2, all I need to do is multiply it by 2 and then divide it back by 2. It's 3 right here. When I multiply it by 2, it becomes 6. And then put back the 6 over 2. See? It's true because 6 over 2 is still 3. And then I put this x, no problem. And then here now, when you multiply a fraction and a whole number, you will just multiply the numerator alone. You must not understand that, right? And then this is negative. So it's going to become a negative 1 times the 3 is 3 over 2. Don't forget the equal to 0. Now, what does this work out to? Since they have the same denominator, it will become 6 minus 1. Minus 1 plus 6 is the same as 6 minus 1, which is 5. It becomes x squared minus, this inside there becomes 5 over 2 times this x minus this thing now of 3 over 2. That's equal to 0. So I've gotten to the equation that would have given us those two roots. But the question said we don't want any fractions, guys. We want integers. So because these two of a denominator, those two fractions of a denominator of 2. If we multiply this whole equation by 2, it will cancel away these two fractions, these two denominators, and give us only whole numbers. So we always multiply through by the highest common, lowest common multiple of the denominator. In this case, is just 2. So we multiply through by 2. All right? We're going to multiply through by 2. Remember, we multiply through by the 2, you multiply this by the 2, multiply this by the 2, you multiply that by the 2, multiply the 0 by the 2. You have to multiply each term by the 2. Not just these that you're focusing on. You have to multiply each term in the expression by the 2. All right, so I'm leaving those arrows on the diagram. So if you multiply the equation by 2, you multiply each term in the equation by the 2. So I multiply this x by the 2, this x squared, sorry, by the 2, it becomes 2x squared. When I multiply this by the 2, it cancels the 2 under here. I end up with minus 5x. When I multiply this by the 2, again, it cancels the 2 under here. I end up with minus 3. equal, multiply this 0 by 2, it remains 0. That's what happens. So I multiply each term in the expression by 2, and the fractions are now gone. So this equation would give us the same 2 roots that we have up here. This equation will give us the same roots, same 2 roots. Just that we have no written equation without fractions. But that equation will give us those 2 roots. We're ready for the function now. Remember, the equation will give us the roots. We're trying to form the function. All right? So from here now, we need to check if the function matches the graph. And the answer is yes. Because the square term on the equation is related to a smile function graph, which is what we have. And when the square term is positive, the graph will have a smile shape. Additionally, this is the c-value in the equation. It relates to the c-value in the function of a smile graph will be negative. And this is negative, and this point is also on the negative side of the y-axis. So we have consistency there. They match. They are consistent with each other. And so, as that is the case, you know that this equation is consistent with this function graph over here. There we have a match. We can say this matches the function graph. So we have a match. And because we match, we don't need to change anything. The function, therefore, will have the same values as the equation. So the function is the same expression as the equation. Y equals 2x squared minus 5x minus 3. This is the function that will give us the entire graph. That's the function for the entire graph. This equation is just for the 2 roots. Remember, could have been that a smile, a front, sorry, that are the same 2 roots. That's what we have to do to check. All right, so this is the function. And now that we know the function, they want us to take the value for P, Q, and R. So comparing that with this. All right, comparing those. And so we can see that the P is equal to 2, coefficient of x squared. The Q, this plus Q, is a negative 5. So the Q is negative 5. And this plus R is negative 3. So the R is negative 3. All right, so R is negative 3. Those are the values of P, Q, and R. And then we're also required to state the coordinates of this point, which is the y-axis intercept, which relates to this C value. In this case is R. It's the same thing again. Right? Simply put, the coordinates of C is going to be 0, R, which is in this case, it is 0, negative 3. And that is the answer for the point C, coordinate of the point C. Done, nice and easy, quick and fast. That's how quickly we should be able to finish the class, right? I know that we're just starting on making progress, okay? Or quickly the question can be done. But when we attain mastery, we'll be able to finish this question in like 5 minutes or less, as I just did. All right, rather than taking so long, but no problem. Learn progress before perfection. All right, guys. So then we come to number 2 of this exercise, number 2. And after this, we have 2 more questions to do, and then we can call it a week. All right, and we'll try not to go past 2 hours on a Saturday. Because we can get through what we're doing on a Saturday, the better, because I want persons to be comfortable watching over the video. I don't want it to be too long on a Saturday. All right, so let's finish this up. So I have this question now to do. So I will need spare time of this video. All right. Just I did not mention them as simultaneous equation, so that's what we are. But to ask us to find the point of intersection. When you find the point of intersection, you can solve the equations simultaneously. All right. So what are the 2 equations? On the line, on the curve. So the line is 2x plus y equals 7 at 9, and the curve is x squared minus xy equals 6. So this is the line, this is the curve. Now we're going to use the substitution method. We want to make one of the variables the subject of the line in particular. Based on the fact that we have a y here by itself, we can take this 2x and transpose it, and then y will become the subject. So we're going to do that. This equation written with y as the subject becomes y equals 7. And we take this 2x and carry it over, it must change sign to minus. It becomes minus 2x. So this is the line that we're working with now. It's the same line, you know, as this, you know. And this is the same. And we're working with the one where y is the subject. So this is the line. And this now is the curve. And shift the curve around. We're going to use a substitution method. Remember what we said? The value of y on the line and the curve, they are equal, they are the same. The line is telling us that the y value is this. So the y value right now is this. So we don't know the actual value. It will be 10 or what. If this was 10, then this also will be 10 at the point of intersection. Just that we don't know what the absolute value is of y on the line. But we know that it is equal to this thing. The y is equal to this thing on the line. We don't know the absolute value. On the curve, it has the same value as that. So we can use this and substitute it in the curve. So we know that they are the same value. They are equal at the point of intersection. Those two values are the same. And so we are free to make that substitution. It will be true at the point of intersection. The y value in the line and the y value in the curve is the same. The line is telling us that the y value is this. We can use that same y value in the curve right here. That's how we use the substitution. Simplify and solve. All right? So we're going to do it. We're going to substitute the line equation into the curve equation. We're going to sub the line into curve. We're subbing for the y. So we don't know the absolute value. So this represents the value of the y right now. We're going to put it in the curve. When we do that substitution, the curve now becomes, curve is going to become, right what the curve becomes, no, for the line, the y value in it. It becomes x squared minus x. Where the y is, we put in the value that the line tells us that the y is all of this right. 7 minus 2x. And that is equal to 6. We are substituting the line y value into the curve value at the same value at the point of intersection. There's a matter of expanding that out and transposing it into a standard quadratic equation. This is a quadratic equation, but right now it is basic. We don't solve basic, we always solve standard. We have to transpose it over into the standard form before we try to solve it. And remember, when you see these negatives, you have to be careful. If I'm multiplying this out here by this, I'm actually multiplying with the negative x, not just the x. It's a negative x times each of these values I'm doing. Not just the x, the negative x. All right? Pay attention to that. Okay, let's go. So I'm going to expand this now. And I'm going to get x squared, that's this one. And it's a negative x times 7 becomes negative 7x. It's negative x times this negative 2x. Negative x times negative 2x. Negative times negative is positive. And it's the x times this becomes x squared. It becomes a positive 2x squared. Positive 2x squared. That is, I've expanded this right here. And then I have now equals 6 on the right side. So I'm approaching my standard equation, quadratic equation. So I need to put the like term together now and set it out like a standard equation. Make it look like a standard quadratic equation. With the x squared term first, the x term second, and the constant value third equals 0. That's what we want. All right. What are the x squared terms in this? That's an x squared term and that's an x squared term. They are like terms. We can add them together. So 1 of this plus 2 of that equals 3 of it. So that becomes 3x squared. 3x squared. This is the only x term. Negative 7x. And then this 6 needs to come on this side. I need to leave 0 on the right side. So I'm going to take that 6 over, make it become negative 6. And then this equals 0. So I know I have my standard quadratic equation. I just need to solve it now. I can solve it by factorizing, and I can solve it by quadratic formula. All right? Factorizing is a quicker way to do these things. And I see a lot of persons using the quadratic formula, which is fine. But believe me, factorizing is quicker. You have to learn to factorize. Or we'll learn to factorize if you keep dodging it. Going for the quadratic equation. There are questions on the paper that will tell you to factorize. So the best way to learn and master factorizing is to practice it. If you get one to do, use that tool. Try do it. Try factorize. Now, this one is particularly easy to factorize because this number is a prime number. The only factors of 3 is 3 and 1. Right? So when I'm factorizing this, I have a head start. Right? I'm going to introduce these other things here as we go. The factors of 3x squared can only be 3x and x. So I already know those two values in the bracket. Then it is the factors of this that must go here and there. And it must be such that the far product and the near product give you the middle term. It is 7. So I can see already now that is 3 and 2 factors of this I want. 3 and 2 now. I'm going to put the 3 over here. But this far product is going to be making 9x. I put the 2 here. This near product is going to be 2x. The difference between 9x and 2x is 7x, which is what I have in the middle. So I know that that's where the value should go to begin with, right? And then additionally now, when the sign out here is negative, provided the first term is positive, the square term is positive. When the sign out here is negative, it means that you're having 2 different signs in the bracket. 2 different signs in the bracket, 1 positive and 1 negative. Watch this now. Since the middle term is negative, you want the larger of these 2 products to be negative like this. Remember, the far one is 9x, and the near one is 2x. This is the larger one. You want it to be negative like the middle term. To get it to be negative, you need to put the minus here inside here. So the 3x times the minus 3 give me negative 9x. All right? So that is some of the shortcut considerations that you can make. If you can't do all of that, then you can go to the lengthy way of doing it. But I have to show you the shortcut method over time. I need the plus right here. Those are the 2 factors. And you can actually check it. Or you check it. This times this give you this first term. The second value times the second value is what gives you that. Which is true. And then as I said, the middle term is the sum of the far product and the near product. The far product is minus 9x. The near product is 2x. See, they add to give you this negative 7x. So it has been factorized correctly. All right. And now that we factorize it, remember is that this factor equal to 0. So think of it. If I want to leave this as a subject, this equal to the 0. Watch this now. X is going to be, take this 2 and carry it over this side. We're going to become negative 2 first. And then the 3 beside the x, I'm dividing it under the negative 2. So it becomes negative 2 over 3. That's what this factor gives me. the other factor was x minus 3. X minus 3 equals 0. Simple. If the x minus 3 is equal to 0, then take the negative 3, carry it over there. You're going to get the x equals 3. So those are my two x values at the line and the curve intersect. Two x values where the line and the curve intersect. I need to find my y values now. How do I find the y values? Plug these two x values back into the line equation right here. Because already we have y as a subject, so it's easy to find those values. All right, I'm going to substitute them in that line equation. All right, let's go. So now, let's write it in here. I'm going to sub these two values into the line equation, which is y equals, what is it again? Y equals 7 minus 12. That's what it is. 7 minus 12 right here. I'm subbing those two values. First one is minus 2 thirds. I'm going to write it at x equals minus 2 thirds. The y value becomes 7 minus 2 times minus 2 thirds. Some of that work in this out. If I have a calculator, I can actually put it in there and just work it out. But I can work it out step by step. So y equals. Now let's work on this part first. That's a minus 2 multiplied by this fraction. Remember, multiply a whole number by a fraction, multiply the numerator. That becomes a positive 4. It's minus 2 times minus 2, positive 4. That becomes a positive 4 over this 3. Over 3. That's what this became. Then this 7 now, I need to put it here. But because this turns out to be a fraction with 3 on the denominator, I want to turn this 7 into a fraction with 3 on the denominator. So all I need to do, because I want to turn into a fraction with 3 on the denominator, I'm going to multiply it by 3 and then divide it back by 3. That's what I'll do with the 7. When I multiply it by the 3 first, it becomes 21, and then I divide it back by 3. Everybody know that 21 over 3 is 7. You know that these are the same denominator. I just simply now need to add the numerator values and put by the common denominator. So the y becomes 25, 21 and 4, 25 over common denominator. It means that one of the points of intersection has this as the x value, put in the bracket, minus 2 thirds, and this as the y value, is the y value. That's one point. The second point is where x equals 3. I'm going to work out that second point now. I'm going to say at the point where x equals 3, take that 3 and substitute it into the line right there again. All right? That y value becomes 7 minus 2, and this x, I'm going to put it as 3. Well, that is a 6 minus 6. 7 minus 6 is 1. This is y equals 1. So the second point is where x equals 3 and y equals 1. That's right. Now. Second point. Is the point 3 is the x value, 1 is the y value. So these are my 2 points of intersection. This one and this one. Those are my 2 points of intersection. But good? But it's still there? Sound awfully quiet.
Understand, sir.
Huh?
Good, sir.
I understand. Beautiful. Remember, I know. If you don't understand something, just jump in and say, sir, explain that again, all right? Try my best to explain it, but if I say something I don't understand, just jump in and say, sir, explain that again, please. All right. And then I sent you 2 questions last night because more math equals better math every time. So I sent you 2 questions last night. Let's see them. Where are those 2 questions that I sent you last night? Hopefully somewhere. I didn't see them. That I did. Test and last time. Oh, there's a question that I gave you. For those two questions last time, there's a question that I gave you on January 24th. And that one for January 24th. January 24th. The question I give you, if you never do I don't master this thing, more people become maths. Good. I gave you this question as well. There's a past paper question. This was one of the only times that they give this thing where they give a question where they give you the roots, as you can see. And they just start asking for the function. So we're gonna start it for you. And this question I wanted to find B and C. But just that they kind of channel the part to the question too, right? This one, they kind of channel you step by step. They want C first, you want to show say B for -4 and all of that. Right? And then they eventually want to do the one point. All right, so that's what this question was about. But what I'm going to do, I'm going to use the approach. We're going to just work out the whole function for yourself. We already know that the C is -5, and we could see it right here. So the C is -5. And this question will look like almost like a free question. Right? Right? And it's 2 master gate first. Right? But look here now, see? This is question knowledge again, like a knowledge-based question. State the root of that equation. See, I put P for 0, guys. Remember? Equation. Okay? Equation. We give it a function in the guys. Give us the whole function in it. So the y in it. Alright? But the equation is what gives us these two roots. Testing knowledge of that, you can know that the equation will give it two roots. You have to solve it, just it's on the graph. Alright? So that is it. The answer for this one is that it is x equals, if x equals, this answer for this one, it is 2, right? 2 and 5. The answer for this, if x equals -1, x equals 5. That's the on the graph. Then it says for the function, I want us to tell them what C is. C and the function relates to the y-axis intercept. So the C is -5. For that one, C is -5. Then they said we have to show that the B is -4. And there are multiple ways to do it, but I'm going to use the method that we've been using, which is that we're trying to form the equation. There are multiple ways to do it, guys. Multiple ways, but because we're practicing this way that we're doing, I'm going to use that approach. So let's say the roots are -1 and 5. And so the equation using the sum of the property root would be x squared minus the sum of the root times x plus the property root equals 0. So it is going to be x squared minus the sum of the roots from -1 plus 5 times x plus the property root from -1 times 5 equals 0. And so x squared minus, and this becomes 5 minus 1, it's 4. So it's -4 And then this works out to be negative 5 equals 0. And we basically have the equation now. No, not the equation. Right? We basically have it now. Right? The same equation now. X squared. Right? We basically have the equation. X squared plus dx plus c equals 0. So we compare the value. And this negative 4 is this plus b coefficient of x. So the b equal negative 4. And then this minus 5 is plus c. So the c equal minus 5. And you have answered these two questions using this method, this approach. Just like that. Right? Just like that. Then now, everybody go with that? But okay?
Yes, sir.
All right, beautiful. And then the next part now is telling us to get the coordinates of the minimum point on the graph. Remember, I told you the minimum point is here. And the line of symmetry passes through that point on the vertical. And what happens now is that these two roots are the same distance from it here. Whatever the x value here is the x value down here, xt, yt, is the turning point. This has the same x value at this point. So right here is also x value at xt. What happens is that the two roots, because this is a line of symmetry, the two roots is the same distance from them. So this distance is the same as this distance. It's like a midpoint between them. That is the average between them. And so that xt value, let me do it over here, becomes the average of the two roots, r1 plus r2 over 2. This is r1, this is r2. Right? So the x value at that point becomes minus 1 plus 5 over 2. So the 5 minus 1 is 4. It becomes 4 over 2. And 4 over 2 is 2. xt is 2. That's the x value at turning point. And then when you know the x value at turning point, you can use a function. Remember the function is, what is the function? Right in blue. Function is this, you know? Function is what gives you a point and graph, you know? It is y equals x squared minus 4x minus 5. That's a function we wrote out a while ago. So it will be this, right? That was the expression. The function will be the same, right? So all we have to do now to find the yt is take this 2 and plug it into it. That's going to give us yt, right? So the yt would be 2 squared right here minus 4 times, this becomes 2 minus 5. This works out to 4 minus 8 minus 5. That's negative 9. That's xt, and that is yt. It means that the turning point, xt, yt, is 2, negative 9. That is it. Well, let's do it the other way that we're familiar with, right? I'm just showing you this method. More math equals better math. So remember, going back to the traditional way, the function is y equals x squared minus 4x minus 5. xt is minus b over 2a. Let's work it out. xt is minus b over 2a using that formula approach, which will be minus, the b is negative 4. That's negative 4. Minus a negative 4. I put it in a bracket. Divided by 2a. A is the coefficient of x squared, which is 1. Good? So it becomes a positive 4 over 2. That's a positive 4 over 2, which will equal to 2. Same 2 that we got up here using the average of the two roots. Average of the two roots. The yt now is in the formula method. with 4ac minus b squared divided by 4a. And that would be 4 times a. The a is 1. In the standard form, the a is 1. Times c. C is negative 5 minus the b is negative 4. All over 4a. 4 times a is 1 again. But then this becomes, negative 9 as well. So write it out here. This becomes negative 20. It becomes negative 16. And this minus still minus. And this comes at 16. So it becomes minus 16 over 4. Minus 20 and minus 16 is negative 36 over 4, which is negative 9. We got the same YT. I think doing it this way up here will be easier up here. We recognize that XT is the average of the two roots, that equals 2, and then we'll take the 2 and plug it into the function here to find the YT. It's easier this time to do it that way. All right, so that was that question there. And then maybe I just need to write the 2 questions that I gave you last time. Apparently I don't have it on this device. I had it on the device. Let's see. I had it on the device. But I put it over onto this device. Apparently I didn't as yet. So let me just write it out. Let me look back in the chat. All right, so we have 15 minutes to finish. Practice a lot, guys. Just practice. I'll give you these two here. I must start them off here. I'm good on fire. All right. But I know I'll give you them to do. For those of you who did it, let's just check what they did. More of the same, really. So the first one was 2y plus x equals 1 to solve simultaneously with x squared plus 4y squared equals 5. All right, solving these two equations simultaneously. I'm going to make x a subject of this one now. Because it's easier to make x a subject, right? Could have actually made 2y the subject and I'll show you something. Yeah. More math equal better, man. Let me make 2y the subject and show you. I think most persons made x the subject, but let me show you something. You know why I'm doing that? Because this is a perfect square of that. That is why I'm doing it. Because this can be written as 2y all squared. I'm going to do it that way. More math equal better, man. Let me stick to that. Let me stick to where we're going to do. No problem. Let's stick to, I don't want to confuse it. Let me stick to x equals 1 minus 2y. All right, we get more advanced. I'll show you these other things. All right, I'm take this 2y and bring it over here. I'm trying to make this x a subject. I'm going to substitute for x. So this is the line. And this is our curve. All right, and as I said, the point of intersection, this x value and this x value is the same. The line is telling us that the x is actually equal to this. Could have been 10. If that was 10, then we could have replaced this with a 10, but these will be the same. Because we don't know the actual value of this, but it is what the line is saying it is equal to. At the point of intersection, they are the same. They are the same. So I can take all of this. The line is saying x is equal to, and bring it and replace the x over here. Is it? Substitute because they are the same value as a substitution method. the same value at the point of intersection of the line and the curve. So I can make that substitution freely. So let's see what we're doing. We're subbing for sub the line with the x, sub the line into curve for the x this time. We'll do that substitution. This thing, this curve, it will become. It's going to become x squared. No, not x. In all of this connect. Sorry about that. It's going to become 1 minus 2y all squared. That's where the x squared was. I'm going to put back everything here. Plus 4y squared equals 5. All right. And then this is a quadratic equation. We just need to expand it out to the standard form before we try to solve it. Right now it is basic. Remember, expand this perfect square, you're going to get 3 terms. First term squared, partial product of the 2, second term squared. That's what will happen when you expand a perfect square. First term squared, 1 squared is just 1. Then twice the product of these two things. What do? You multiply them first and get minus 2y. And you have to double the minus 2y to minus 4y. I'm going to get minus 4y. That's twice the product of the 2. Then I have to square this term next. Square it. That's the second term squared. It's going to become plus 4y squared when I square this right here. Then this now is coming back. It's the same thing. 4y squared. I get plus 4y squared equals 5. Let me underline it. This one is this one. And this is going to expand with that. All right? I'm going to put the like terms together now. So this is a square term. These are square terms. They add to 8. 8y squared. 8y squared. This is the only y term there. That's a minus 4y. Then this 5 is going to come over and become minus 5. And put it with this 1, I'm going to get negative 4. Negative 4. Minus 4. And I'm going to put equals 0. So it's in the standard form. But this can be simplified. I'm going to divide through by 4. I'm going to divide through by 4 to simplify it. Or divide 2 by 4, divide each term by 4. So divide this by 4, it becomes 2y squared. Divide this by 4, it becomes minus y. Divide this by 4, it becomes negative 1 equals 0. This factorizes easily because the only factors of this is 2 and 1. Only factors of this is 1 and 1. So this don't need no process to factorize. All right? So it's no matter where you put the plus and the minus now. So the factors of this must be 2y and y, 1 and 1. The middle term is a minus y. So remember, the far product and the near product gives you the middle term. The far product is 2y, the near product is y. Since the middle term is negative, you want the larger of these two products to be negative. This is the larger one. You want it to be negative like the middle term. I'm going to put the minus here and the plus there. That is it. Those are the two factors equals 0. And then now, what happens next is that if this one equals 0, then the y is going to be equal to minus a half. Or the minus a half. Take the 1, carry it over first, become negative 1. And then take the 2 and divide under it. It will become negative 1 over 2. Or the other point is where this equals 0. Take negative 1 and take it over there. It becomes y equals 1. We're not finished yet. These are just the y values are found already. I need to find the x value to go with this and x value to go with that one. Where do I get them from? Plug them back in the line equation, which already has x as a subject. To find the y value, to find the x values. I need to find the x values now. All right, so I'm going to sub them into that equation, x equals 1 minus 2y. Let's write it out. I'm going to sub into line equation, which which is x equals 1 minus 2y. Show you that. Yes, 1 minus 2y. Firstly, at the point where y equals minus half, take the minus half and put it in there for the y. The x becomes 1 minus 2 times minus half. So the x becomes 1. This minus becomes a plus, and 2 times a half is 1. This becomes 2. So 1 point. What is important now, guys, I will put x value first in the bracket, even though we calculated it second. I will put it first in the bracket. That one is 2, y value is negative half. The other point is where y equals 1. So at y equals 1, I'm going to take this one and substitute it in here now for the y. So the x at that point is 1 minus 2 times 1. 2 times 1 is 2. 1 minus 2 is negative 1. So the x equals negative 1. So the second point of intersection, second point, we'll have this x value first, minus 1, and then this y value second in the bracket. But then, since even though we calculated x value second, it must be placed first in the bracket. Is that? Very good? But okay? We have one more. We're doing 5 minutes. But okay?
Yes, sir.
Yes, sir.
The next one was but I gave a line and a curve. So I'm going to write the line first, right? So the line I gave you was 3x plus y equals 1. And the curve I gave you was 4xy plus 5 equals 0. And this can be done more to be it, but I'm going to practice the substitution way again. Still going to practice substitution way. So this one can make y the subject by transposing this 3x on the line. So y is going to be 1 minus 3x. 1 minus 3x. All right. And this one is a line. And this one is a curve. But the curve is the one that has products and quotient of x and y. That's a product of x and y. That's a curve. All right. So I'm going to do the substitution again. The line is saying y equals this. The y value here is the same as that. But the y value on the line and the curve is the same at the point of intersection. So let's show it again. More math equals better math. You must get this now, guys. Must. Practice it for me, please. Practice it. So that's what the line is saying y equal to. Would have been 10. If it was 10, then this value would be 10 as well. But it's not 10. We don't know the absolute value that it is. We know it is 1 minus 3x. No problem. Treat it as you would treat a value of 10. You can take that value and put it in the curve where the y is, right here. Because at the point of intersection, the line and the curve have the same coordinates. Same x values, same y values. It's just convenient to substitute for the y value right now and work out the x values. All right? So let's see it again one more time. We are subbing the line equation into curve equation for the y. And it is this that we are subbing into. This is what is going to change that we're subbing into. So I'm going to put by the 4x. Where the y is, I'm going to put this value now, which is the 1 minus 3x. Plus back this 5 equals 0. So this is now my quadratic equation, just that it is basic. And to expand it out and transpose it into the standard form and solve it. I'm going to multiply this 4x by the 1 first and get 4x. Then this 4x times this minus 3x. So the negative 12x squared minus 12x squared. And then this plus 5 equals 0. So see my square term negative this time. I don't like when my square term is negative. Quadratics are easier to do when the square term is positive. What I'm going to do to get my square term positive, I'm going to multiply through with a negative 1. All right? Because I already have everything on the left side and 0 over there. So I just need to get my square term positive. All right? So I'm going to multiply 2 by minus 1. I'm going to multiply this by minus 1. I'm going to put the arrow showing. Multiply each thing by minus 1. Each term. In the 0 over there. All right? When I multiply this by the minus, well, do the square term first. I want to put it in front. I get positive 12x squared. Then this one next, I get minus 4x. Then this one becomes a negative 5 equals 0. Then this can be factorized. Let's see if we can factorize. Only factors of this is 5 and 1. So we can have a head start. We can try some values. So we know that this is 1 and 5. Factors of this is 1 and 5. Question is, what are the factors of this? Middle term must be 4. What am I seeing? Let's try 6 and 2. Yes, 6 and 2 will work. I want to put the 2x right here and this 6x right here. Oh, I see that. But this is going to give me 10x. It's going to give me 6x. The difference between 10x and 6x is 4x. After a while, you'll be able to do stuff like this, guys, and do it quickly. All right? So don't worry about me doing it fast. Focus is not how we do this right now. There's the AC method if you want. But that's where the value is going to be. And then now the middle term is negative. The large of the far product and the near product must share the same sign as the middle term. Remember, the far product is 10x. The near product is 6x. I need this one to be negative. So I have to put the minus here and put the plus here. So it's minus 10x plus 6x give me this middle term. So those are the two factors right there. Nice and easy. And then now if this one equal to 0, you have to carry over the 1 first. Take the 1 and carry it over first. I get negative 1. And then take the 2 and divide under it. Or if this one equal to 0, then the x would be equal to, take the negative 5 and carry it over first. Over positive 5 and then take the 6 and divide under it. Negative 5 over 6. Those are two x values. Two fractions, no problem. What we have to do now to find a y value is take these two x values and substitute them into the line equation that has y as a subject already. All right? And let's work. We want to do that again. 1 minus 3 to the line. Let's work it again. I take these values, I want to sub them into the line equation, which is y equals 1 minus 3x. Right? Firstly, at the point where x equals minus half, that's this one right here. I'm going to take this minus half and put it in the x there. So y becomes 1 minus 3 times minus half. All right? Let's work this out first. So the y becomes, let's work this out first. Well, the minus and the minus going to give me a plus for sure. I'm going to multiply this 3 by this negative 1. And becomes a positive 3 over this 2. And then this 1 now, I want it to have a denominator of 2. So easy. 1 is same as 2 over 2. Simple as that. This works out to be 2 plus 3 is 5 over 2. I replace the 1 with 2 over 2. So that these two have the same denominator. So it means that 1 point is this x value and this y value. 1 point of intersection. 1 point is minus half 5 over 2. So the second point is where x equals 5/6. So at x equals 5/6, I'm going to take the 5/6 and substitute right here with x. I'm going to get that y at that point is 1 minus 3 times 5/6. What happens here now? If you look at it, the 3 cancel into this 2 times, right? And it is negative. So again, let's work this out first before we write what fraction we need for that. Let's write 2 again. So the y is going to be equal to, let's work this out first. It's going to be negative. And let's take 3 into this 1 time, 3 into this 2 times. So we have 2 on the denominator. So it's going to become 5/2. And then this 1, I want to turn to a fraction of the denominator of 2. It is 2/2. I like to multiply it by 2 first and then divide it by 2. It becomes 2/2. All right, so that is that. And then 2 minus 5 is -3. So it becomes -3 over a common denominator of 2. So this is my x value. This is my y value at the other point. So the other point, and the second point, are these values. This x value, 5/6. This y value, -3/2. All right, guys, that is it. If you did any of these questions, no joke no. If you did these questions and got anything wrong, you have to do it over again from scratch. More maths equals better maths. So anything that they got wrong, you need to redo it. Do the question over again. Okay, Miss Elizabeth?
Yes, sir.
Okay. All right, that goes for everybody, right? Aaron, Alfred, Gio, Bladen, Julian, Carl, Ocean, Stefan, Xavier, and Zara. And all the other students who are not here, you can watch the recording. So even you who are here, I'm going to send the recording into the group. You read the questions, watch the recording as you go. If you make a mistake, you read the question. You do the question, you use the videos to guide you. We're moving on to a new topic from tomorrow. Next time you see quadratics is in December, we'll do a revision. All right, we're moving on to a new topic from tomorrow. We've done the quadratics for a while. All right, guys, so hope you're all at a level now. I think you're at that. I think I'm comfortable at the level that you're at. Just that the students who joined the program late, I don't know exactly where they're at right now, but not to worry, we're gonna fix whatever we need to fix later on. All right. We're moving on to a new topic now from tomorrow. Tomorrow and Monday. All right, guys. I see you in class. I'm gonna send the video. Make sure you watch it over again and redo all the questions, especially the ones that they got wrong. Anything you got wrong on any question, redo the whole question. All right. Bye, everybody. See you in class.
Bye, sir.
Okay. Bye-bye. End the session right now.